Hello everyone. Today in this session we shall discuss about ammonia. Ammonia is present in small quantities in air and soil. First let us see its preparation from urea. It is prepared from urea. This is urea, NH2CONH2. It is urea. It has got highest content of nitrogen to an extent of 46.6%. So ammonia is obtained by heating urea. So urea with water, first it gives ammonium carbonate. This ammonium carbonate decomposes to give you ammonia, then carbon dioxide and water. And next process is manufactured by Haber's process. Ammonia is manufactured by Haber's process. It is also called Haber-Bosch process. Here nitrogen reacts with hydrogen in the ratio 1:3 to give you ammonia with the liberation of heat, that is 46.1 kilojoules per mole. Here this is a reversible reaction. So what happens after the reaction starts, and at certain point the reaction attains equilibrium state, that is the concentration of both reactants and the products become equal. Then how to get ammonia in more quantity, or how to favor the reaction in a forward direction. If the forward reaction favors, we get more ammonia. That you have studied last year in chapter equilibrium. So we have to remember or recall Le-Chatelier's principle, which says when a reaction is at equilibrium, whatever we do, the equilibrium does the opposite. So let us see the conditions to get more ammonia. So the conditions to get more ammonia, or the condition for the forward reaction, what we say. See here, if you remember the Le-Chatelier's principle. Now this reaction is exothermic, means it is giving energy. So to favor the exothermic reaction, we have to lower the temperature. So lower temperature would favor the formation of ammonia. But in general, the rates or the speed of the reaction increases with increase in temperature. So low temperature slows down the rate of the reaction. That is why an optimum temperature is used around 700 Kelvin. So it should be provided. Coming to the pressure, here in the reactant side, see here 1 mole and this one is 3 moles. So reactants are 4 moles and products are 2 moles. So 2 moles of products. So if we apply high pressure, the reaction goes in a forward direction. So high pressure around 200 atmospheric pressure is applied. Coming to the catalyst, which increases the rate of a reaction. Here use of a catalyst such as iron oxide, which increases the rate of a reaction, along with some substances like potassium oxide and aluminum oxide. So these are acting as promoters, which increase the catalytic activity of the catalyst. So these are known as promoters. So with these conditions, nitrogen and hydrogen in 1:3 ratio reacts at 700 Kelvin and 200 atmospheric pressure in the presence of iron oxide catalyst and potassium oxide and aluminum oxide promoters. It gives you ammonia. Now we'll see the flow chart for the production of ammonia. Now we'll see the flow chart for the production of ammonia. Here these are the two inlets and this is a compressor and it is a catalytic chamber. Now what happens? Nitrogen and hydrogen in the ratio 1:3 by volume are passed into a compressor. Here the gases are compressed to 20 megapascal or 200 atmospheric pressure. The gases are compressed. Then these are made to enter the catalytic chamber. Here iron oxide catalyst is kept along with the mixture of aluminum oxide and potassium oxide. Here the temperature is maintained at 700 Kelvin. The reaction begins and ammonia is formed. Ammonia along with the unreacted nitrogen and hydrogen is passed into cooling chamber. Here ammonia starts liquefying and the unreacted nitrogen and hydrogen are again pumped back to the compressor using this pump. Now let us see its structure. See here, nitrogen here is sp3 hybridized. It has 4 hybrid orbitals containing single electrons. Out of 4, 3 orbitals overlaps with hydrogen atom to form a single bond and a fourth one has a lone pair of electrons. Actually the expected structure is tetrahedral with bond angle 109.5 degree. But according to VSEPR theory, valence shell electron pair repulsion theory, valence shell the repulsion between the lone pair and the bond pair decreases the bond angle from 109.5 to 107 degree. So the structure is trigonal pyramidal with a bond angle 107. It decreases from 109.5 to 107 degrees. Now let us see some chemical properties of ammonia. You know, ammonia is basic in nature. It acts as a Lewis base and ammonia reacts with acids to form salts. For example, ammonia with hydrochloric acid, it forms ammonium chloride, which is a salt. Similarly, ammonia with sulfuric acid, it forms ammonium sulfate. Another important compound is ammonium hydroxide, which is obtained by dissolving ammonia in water. So this ammonium hydroxide, it is used to identify the nature of metal. For example, this ammonium hydroxide will give dirty green precipitate if it is treated with ferrous sulfate or ferrous salts. It can give white gelatinous PPT which is soluble in excess of ammonium hydroxide on treating with zinc sulfate. Similarly, we get a brown PPT if it is treated with ferric chloride. That means this implies it is used to identify the nature of metals. If it is dirty green, it is ferrous salts. If it is white, then it is zinc salts, like this. Another very important property is ammonia can form coordinate complexes. See here, ammonia can react with certain metals to form coordinate complexes or coordination compounds, because nitrogen has the ability to donate lone pair of electrons. For example, Cu+2 ion, when it is treated with ammonia, we get CuNH3 4 times +2. That means copper is surrounded by ammonium ions to form a complex of copper and ammonium with +2 charge on the coordination sphere. Similarly, silver chloride with ammonia, it forms a colorless complex compound AgNH3 twice Cl. These clearly says that ammonia has the ability to form complexes. This special property is because ammonia can donate lone pair of electrons. Thank you.